right, so what we're going to do today is talk about some basic trig definitions. Some of this you're going to know, some of this you guys will maybe know, I don't know, so we'll see. Alright, so basic definitions. You're going to have a right triangle, you've got an angle theta. Again, it doesn't have to be down here in the vertical, it could also be up on the top. Okay, hypotenuse is obviously always going to be the side opposite the 90. The angle, the side that does not make up the angle we're talking about directly across is always going to be considered our opposite side. And the side that is next to is going to be the adjacent. So we're going to call it H and O and A. So sine is by definition, it's going to be my opposite side over my hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. You guys know that, of course, by your good old SOHCAHTOA thing. For cosecant, secant, and cotangent, those are going to actually be the reciprocals of what's going on. So cosecant is the hypotenuse over the opposite. Secant is the hypotenuse over the adjacent, and the cotangent is the adjacent over the opposite. And so that's why I kind of call these the cousin functions, because now sine and cosecant are related. Secant and cosine are related. And then tangent and cotangent are related. They're just going to be reciprocals of each other. And in fact, after the basic definitions, that is what's going to end up coming into the reciprocal identities. Because since they're the opposite, sine is going to be the same thing as 1 over the cosecant of theta. So if you have cosecant of theta, you know, that's also going to equal 1 over the sine of theta. So you have one, you can always write it down on the other side of the fraction as reciprocals of each other. Cosine is the reciprocal, reciprocal of cosine is 1 over secant. Secant is also equal to 1 over cosine. Okay. Tangent, the reciprocal of tangent turns out to be cotangent of theta. And cotangent theta is going to equal 1 over tangent theta. You are expected to know these. We're going to get to the point when we start doing trig proofs that I'm just going to throw these out. And I'm going to expect that you guys can throw these out. And I'm not going to spend a lot of time constantly going back and saying, oh yeah, cosine is 1 over secant, or secant is 1 over cosine. So, there's that. Now, reference angles. Reference angles are the angle made from the terminal side to the horizontal axis. You are never going to the x-axis, the y-axis, you're always going to the x-axis. So in this case, the reference angle here, okay, this is your reference angle for here, you know, for this other angle over on this, for this angle here. Okay, because when we're dealing with these things, everything's always, the reference angles are always going to be based off of the angle that's made between the terminal side and the horizontal axis. So this is your reference angle. Okay, even though, so let's say this angle up here, this angle right here has a length of, let's say, 150 degrees, your reference angle is going to be 30 degrees because they're supplementary. So sine, cosine, tangent, and all that other stuff of 150 degrees is going to be based off of the reference angle of 30. So you're going to see a lot of similarities between 150 degrees and 30 degrees in terms of sine values, cosine values, etc. Okay. Now, if you had one, let's say your reference angle is here. Okay. The reference angle that we're talking about is this one right here. Okay. So so this angle right here might be, let's say, that's the measure of angle is equal to 255 degrees. Okay, your reference angle, the measurement of your reference angle, is going to equal just this part right here. So in that case, it's 180. So the first 180 doesn't count. That's going to end up equaling essentially 255 minus 180. Now, I'm not going to give you guys rules on this because, again, look at the problem. This is 180. This has to be balanced. The balance of the 255 has to be your reference angle. Period. Done. End of story. Okay. Again, this is all stuff that you should probably write down, and if you haven't, go back and fix it. If we have a reference angle over here, let's say the angle that we're talking about, we're going to come all the way around here. Let's say that's 290 degrees. My reference angle is this angle right here. So how much more do I have to make up my reference angle? Is going to be the difference between that and the 360. So how much do I have to go complete out the circle? 70 degrees. You're going to have to do that over and over and over again. So you're going to, a bunch of what you're going to be doing in 5.2 is finding reference angles, referring to reference angles. General side of an angle theta is in standard position, so that means that, okay, I'm going to go in standard position. That means, again, your initial side is at 0 degrees. Passes to the point 12.5. Sketch the angle and find the values of the 6 trig identities and functions. Okay, this is going to be essentially stuff you guys did last year in geometry. So you have your axis. So you've got 12.5. So I'm going to go over 12, up 5. So this is a side of 12, 5. So that has the point 12, 5. The angle that we're talking about, let me get rid of that. Actually, that should be a ray, just to be nice and clear. Okay, so we have this ray kicking out from here to the point 12.5. Which means that the altitude here forms a right angle. That's 5. This is 12. So then, because it's a Pythagorean triple, now you're going to go through and you're going to find sine, cosine, tangent, etc. Your angle is this angle right here. So then you're going to have to go through and you're going to have to find all the sides. So let's say for sine of theta, that's equal to opposite over hypotenuse, right? Opposite over hypotenuse. My side opposite is 5. This is a 5, 12, 13 right triangle. So that means that this is, hypotenuse is going to be 13. If you're not sure about it, leg squared plus leg squared equals hypotenuse squared. So that's going to be 5 over 13. Your cosine of theta is going to be adjacent over hypotenuse. So that's going to be 12 over 13. Your tangent of theta is going to be opposite over adjacent, which means that's going to be 5 over 12. And then you have to go through and do the other 6 as well, or the other 3 out of the 6. And so I want to know what cosecant is. Cosecant theta is hypotenuse over opposite, or you can say the reciprocal of sine. So that'd be 13/5. Secant of theta. And again, do not call this sin, cos, tan, secant, sec, and see what we call it, cot. Okay, none of that. Okay, call it what it's supposed to be. So then this is hypotenuse over adjacent, so that is going to be 13 over 12. Cotangent is going to be adjacent over opposite, so that is going to be 12 over 5. And those are your 6 values. And that's all you do. So you need to figure it. Now the one thing you do have to worry about, I think this is on the next slide, yeah, is you are going to have to care about what the values are. So like in this case here, when you draw this out, the point that we're talking about is 8, -6. So that's going to be out over here. So 8, -6 is down here in quadrant 4. I'll write that so it's a little bit clearer. So you're going to draw out your triangle. The angle that we're dealing with, again, is always made with the horizontal. So you've got your ray here. Drop your altitude back to the horizontal. So this is evaluate, and this is going to be a side of -6. It's going to be important to keep the sign there, because if you don't have the sign there, you're going to get the signs, and the sines, cosines, tangents, etc. all incorrect. So now again, -6, 8, you get a hypotenuse of 10. Nothing else. Remember, leg squared equals hypotenuse squared, but it's based off a 3, 4, 5 right triangle. So your sine, because again, theta is right here. Sine of theta is going to be opposite over -6 over 10. So I'm going to reduce that down to -3/5. My cosine of theta is going to be 8 over 10, otherwise known as 4/5. Yes, you must reduce this because I'm not asking you to do that hard. Okay, the stuff you did back in middle school. And you get -6 over 8. So that's going to be -3/4. fourths. Now all the cousin functions are going to be related to this. So you could say, okay, secant of theta is going to equal a negative 5 thirds. Cosecant, excuse me, cosecant theta is negative 5 thirds because that's related to sine. It's again hypotenuse over opposite. For cosine, I've got secant of theta. That is going to be positive 5 fourths. For cotangent of theta is going to be a negative 4 thirds. Take some time to get all the basic problems down, so then from there we can get all of the harder stuff. You need to take some time, get the basics down, so then that way we don't have to spend time going over it when we should be going over harder things. We'll see you tomorrow.